Hi students, welcome to my lectures on chemical reaction engineering. Okay, today we are going to discuss about rate of reaction for homogeneous and heterogeneous systems. Of course, this entire lecture series about the homogeneous reactions, but it is important to understand how to represent a rate of reaction in homogeneous and heterogeneous system. So, by comparison you can learn many things. And today we are going to discuss about the expressions, how to connect different rate of reactions as per the definitions, and finally we are going to solve one example. So, if you see the rate of reaction for homogeneous and heterogeneous systems, in our last lecture we have discussed about how to put the rate expression. Definition of the rate expression is nothing but 1 by V minus 1 by V into dNA by dt. That means how many moles disappeared, how many moles of reactant A disappeared in a particular volume of the liquid every second. So, that is what the definition of the rate. So, minus Ra is equal to minus 1 by V into dNA by dt. And for example, this is the reactor. What volume, because for the definition volume of the liquid, what volume of the liquid we have to consider? The volume of the liquid, let us say if it is happening inside a reactor, we have to consider the volume of the liquid occupied in this particular reactor V. That means if entire volume of the reactor is occupied with the liquid, then our comparison is based on that volume of the liquid, okay, inside this particular reactor which is V. Okay. From this definition I can say minus dNA by dt is nothing but minus Ra into V. That means I have to, because for some comparative basis I have done that. If you rearrange this equation, this rearranged equation is nothing but minus dNA by dt is equal to minus Ra into V. What is dNA by dt? Na is moles, T is time, moles per second. What is Ra? Mole per meter cube second. What is V in meter cube? Meter cube cancels, then left hand side is also moles per second, right hand side is also moles per second. Okay. Let us, later I will explain why I have rearranged this equation. For case of heterogeneous systems, there are more than one definition for the rate of reaction representation. What are those definitions? And one is Ra, which is talking about rate with respect to the volume of the catalyst inside the reactor, and second rate is Ra dash. This Ra dash is talking about rate with respect to the mass of the catalyst inside the reactor. Ra double dash means this expression talks about the rate with respect to the surface area available on the catalyst, okay, inside the catalyst and on the catalyst. That means this talks about rate with respect to volume of the catalyst, this rate talks about the rate with respect to the mass of the catalyst, and Ra double dash is moles with respect, rate of reaction with respect to surface area of the catalyst. And finally, we are going to relate these three in one equation. Okay, let us do that. Minus Ra is equal to minus 1 by Vs. Vs is nothing but volume of the solids inside the reactor. Okay. While defining the rate, we cannot take entire volume of the reactor. It is talking about Vs, that means volume of the solids inside the reactor. Only you have to consider only volume occupied by the solid catalyst inside the reactor you have to consider. That is why moles disappeared with respect to the volume of the catalyst inside the reactor every second. Okay. From this I rearrange this minus dNA by dt is equal to minus Ra into S. What is this? dNA by dt moles per second, Ra is moles per meter cube per second, Vs is the in meter cube. Meter cube cancels, that means left hand side and right hand side I got moles per second. When you talk about Ra dash, minus 1 by W into dNA by dt, that means moles of A disappeared with respect to the mass of the catalyst every second. That means how many moles of A disappeared per every kg of the catalyst in every second. That is what the definition of the rate is, Ra dash. Okay. What is my dNA by dt? If I rearrange this equation, which is minus Ra dash into W. What is dNA by dt is moles per second, Ra dash unit is mole per kg per second, W it has the unit of kg. Kg cancels out, and left hand side mole per second and right hand side is also moles per second. When you talk about Ra double dash, that means moles of A disappeared per surface area of the catalyst per time. That means how much moles of A disappeared with every meter square surface area of the catalyst every second. Okay, that is what this definition. If I rearrange this equation, minus dNA by dt is equal to minus Ra double dash into S. S is the surface area of the catalyst. Left hand side is also moles per second, right hand side Ra double dash means mole per meter square into second into meter square. Meter square cancels out, I get moles per second. Okay, that means in this reactor, that means whenever we are defining the rate with respect to surface area of the catalyst, you have to count what is the available surface area of all the catalyst, not entire volume. That means only where you have considered the entire volume of the reactor with respect to homogeneous reactions, okay, because everywhere the liquid is occupied and everywhere the reaction is happening. But here, especially for catalyzed reactions, the reaction happens only either in volume of the catalyst or near to the surface area, I mean with respect to the catalyst, whether it with the volume of the catalyst or surface area of the catalyst or mass of the catalyst. That means you have to consider only the catalyst in mind while defining the heterogeneous reactions. Let us compare. This is equation 1, equation 2 and equation 3. 1 is equal to 2 is equal to 3. Why? Because this is also in moles per second, this is also in moles per second, this is also moles per second. That means I can equate these three equations. That means minus Ra into Vs is equal to, this is moles per second, which is equal to minus Ra dash into W, that is in moles per second. This is equal to minus Ra double dash into S, which is in moles per second. So from this equation I have connected, that means rate with respect to, if you know the rate with respect to volume, you can understand the rate with respect to the mass of the catalyst. That means if you know the rate with respect to the volume of the catalyst, you can convert to rate with respect to the mass of the catalyst. If you know the rate with respect to the mass of the catalyst, you can convert the rate with respect to surface area of the catalyst. That means using this equation you can find any rate to the other rate. Let us take the small example. Given rate with respect to the volume of the catalyst is 3 moles per meter cube per second. Okay. Now the problem is you have to find out rate with respect to the mass of the catalyst. That means given volume of the catalyst in the reactor, example 0.1 meter cube, which is V, volume of the solids, okay, Vs, okay, and mass with respect to the mass of the catalyst is 1 kg. Find minus Ra dash. I know from this relationship minus Ra into Vs is equal to minus Ra dash into W. Okay, from this minus Ra dash is equal to minus Ra into V by W. I know Ra, which is given 3 moles per meter cube second, into volume of the catalyst is 0.1 meter cube, okay, divided by weight, mass of the catalyst, 1 kg. You can see meter cube cancels out. The final units you get, Ra dash is nothing but mole per kg per second. That means if you have given Ra, you can find out Ra dash. Similarly, you can, if you given Ra dash, you can able to find out Ra double dash, provided you should know S and W. That means surface area of the catalyst is given and mass of the catalyst is given. Every time you can convert from one rate to another rate. There are other complicated expressions are there, and inside this people have used bulk densities, normal densities. Later on you are going to learn what are all those things. First of all, it's a very simple lecture on representation of rate for homogeneous as well as heterogeneous systems. Hope you have learned. Let us meet with the new lecture. Thank you.